Hello, welcome to our lesson today about elements, compounds and mixtures. We're going to start with a little review of some of the work that you did yesterday. So I've given the symbols for some elements here. What I want you to do is find out what the names of those elements are from their symbols and tell me whether they are metals or non-metals. So if you want to pause the video now and then you can have a go at it and then I'll go over the answers. Okay, so hopefully you paused it. You should have identified that this is the symbol for sodium, this is the symbol for potassium, magnesium, copper, sulfur, phosphorus, chlorine, bromine. This is an element called antimony, and this is the symbol for iron. In terms of metals or non-metals, metal, 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 non-metal, 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 metal, metal. So I'll just move that down so you can see that. The reason I've done this is it's really important for us to recognise that element symbols are either single letter symbols, such as the symbol for potassium here, sulfur, phosphorus, or they are two letter symbols. And if they are two letter symbols, it's a capital letter followed by a little letter. Okay, so if we look at how sodium's been written here, this is correctly written, a capital N with a little a. What is incorrect is that, or that, or that. It has to be written with a capital N and a little a, and it's really important that we recognise that. Okay, so the thing we're going to look at first of all today is what we mean by molecules. Now a molecule is where we have two or more atoms chemically bonded to each other. We'll see as we do chemistry later on that there's different types of the ways that they can be bonded, but they're chemically bonded to each other. So if we have a look at example number 1 here, we've got Fe, which is the symbol for iron, and we've got Cl, which is the symbol for chlorine, but that's Cl2. So this is just iron atoms, and this is the symbol for chlorine molecules. And this is actually the way that chlorine exists in nature. We don't see it as single chlorine atoms, we see it as chlorine molecules. So that we know that that's a molecule because we've got this little 2 immediately after it, and that means chlorine times 2. If we have a look at example number 2 here, S8 and Pb, this is the symbol for sulfur molecules. What it means is sulfur, there are 8 of them. Sulfur exists as 8 sulfur atoms bonded together, and then this is the symbol for lead atoms. And if we have a look at our final example, we've got Br2 and Al. So because we've got more than one atom joined together, in this case it's 2 of them, we say this is a bromine molecule and these are aluminium atoms. So the only thing we want to be able to do at the moment is just identify whether or not something is a molecule or an atom. So let's have a look at some questions. Okay, so I want you to categorize the following as either molecules, molecular substances, or non-molecular substances. So if it's a molecular substance, if we think back to our examples earlier, we had F2, Cl2 I think, and S8, so these were all molecular substances because there were more than one atom. And then our non-molecular substances, for example Pb and Fe, well, we've only got one atom present. So if you want to pause the video and have a go at those, and then I'll go over the answers. Okay, so hopefully you should have, I've just realised you couldn't see the examples from earlier, so if you want to check again, hopefully from these you should have seen that this is molecular, this is molecular, 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 and molecular. So I'm saying all the circled ones are molecular, and these here are non-molecular. Okay, right, we now need to be able to talk about what we mean as an element as compared to a compound. And this is where we need to be careful with our definitions of molecules as well, because we can have molecular elements, non-molecular elements. So, an element is made of one type of atom only. A compound is made of two or more different atoms chemically bonded. So we've seen that idea about chemically bonded before to do with molecules, but we need to see that we can actually have molecular elements as well as non-molecular elements. So if we have a look at example 4 here, we've got F2 and SF6. If we think about what F2 means, F2 means 2 times fluorine atoms. What that means is that this is a fluorine molecule. Although there's 2 atoms, they are the same type of atom, which means that this is an element. If we have a look at this formula here, what this formula means here is we've got a capital S, that stands for sulfur. There's no number after it, which means there is 1 sulfur atom present. We've got F and there's a 6 after it, so that means there's 6 times fluorines present. It's a molecule because there are 2 or more atoms bonded, but this one is a compound. The reason this is a compound is there's 2 different types of elements present, sulfur and fluorine, whereas if we look at our first example, this is an element because whilst there are 2 or more atoms present, they are the same type of atom, so it's fluorine. So it's an element. Let's have a look at example 5 and 6. So this here means there are 60 times carbon atoms present. It's actually a molecule called a fluorine, but they are all the same type of atom. So we say that this is an element. If we have a look at this, this means there are 6 times carbons, 12 times hydrogens, and 6 times oxygens. This is actually, you don't need to know it yet, but this is actually the formula for glucose, which is the sugar that we use in respiration. But because these are all different atoms, we can say that this is a compound. Let's have a look at our final example. K just on its own, 1 times K. K is the symbol for potassium, which means that it must be an element. There's only 1 type of atom present. KOH is actually the formula for something called potassium hydroxide. There are no numbers after all of these, but these are all capital letters, so they're one element. Each represent 1 element. 1 times potassium, 1 times oxygen, 1 times hydrogen, which means that this is a compound. So let's have a look at some questions I want you to have a look at. So our last question here is for us to categorize, to work out whether the following are elements or compounds, and additionally, if you can, also have a workout and identify any of them that you think are molecular or non-molecular. So if you want to pause the video and have a go at these questions, and then I'll go over the answers. Okay, so let's go over the answers. Hopefully we should have identified 2 times chlorines, therefore this must be an element because they're both the same. This one here, 2 times aluminiums, 6 times chlorines, which means this must be a compound. This is just 1 times A, which is the symbol for gold, which means this must be an element. This is 1 times V, which is the symbol for vanadium, which means that this must be an element. This here is vanadium oxide, 2 times V's, 5 times O's. They're both different, therefore this must be a compound. Symbol for molecular hydrogen here, 2 times H's. This must be an element. This is the symbol for water, 2 times H's, 1 times oxygens. This must therefore this must be a compound, as they are different elements. This is just 1 times potassium, which means this must be an element. If we have a look at our last examples here, 2 times bromines. This must be an element, as they're both different. 1 times hydrogen. Sorry, this must be an element because they're both the same. 1 times hydrogen, 1 times bromine. This must be a compound. Here, 1 times sulfur, 4 times Cls. Therefore, this must be a compound, as they are different. And then finally here, we've got 1 nitrogen and 2 oxygens, which must mean that this is also a compound. If we were going to identify the substances that were molecular, many of them are. This one, these aren't because they're single atoms. This is a molecule, a molecule, a molecule. This one isn't. A molecule, 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 and molecule. Okay, there's one last thing we're going to have a look at, and then we're finished for today. And this is to think about what we mean by the terms mixture. Now, a mixture, we can have a mixture of elements, or a mixture of compounds, or a mixture of both. So for a mixture, we have substances where 2 or more different substances, and they can be elements or compounds, that are not chemically bonded, so they're going to be separate from each other. So if we have a look at this first example, in this bubble, this balloon here, we've got nitrogen, 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 N2, 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 N2. All of these substances are the same, which must mean this is not a mixture, and we'd actually say that this is a pure substance. It's actually a pure element, but we'd say it's a pure substance. If we have a look at example number 8, NO2, 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 NO2. These are, hopefully you recognise the symbols for a compound. In this case it's nitrogen dioxide, and they're molecules, but they're all the same. Same. So we'd also say that this must be a pure substance, but in this case it's a pure substance of a compound. If we have a look at example number 9, we come to something that's slightly different. N2, CO2, CO2, NO2, N2. That's different to that. That is different to that. So this must be a mixture. These are different and they're not attached to each other. Whereas how this one was different to this here is, whilst this is a compound made up of 2 different types of atoms, they are all the same as each other. That's the same as that, the same as that, the same as that. Whereas here, these are not the same as each other, so this must be a mixture. So just to finish up, here are 3 examples, if you want to copy them down and identify them as pure substances or mixture. Pure substance or mixture. If you want to pause the video and then I will go over the answers. Okay, so hopefully you should have recognised that this is a pure substance, this is a mixture, and this is also a pure substance. You could have hopefully identified maybe that this is a pure element and this is a pure compound. Thank you very much.